is a big kind of noise in the agile industry, and he calls it improving the value curve. Obviously, what we have up there is your traditional project, big bang, big risk, all the value is delivered right at the end of the project, and that's no good. And then obviously what we have is big increments, is things like Scrum, and we have small increments, which is a slightly more flexible way of doing things. And as you can see, the value is being delivered during the course of the project. But if we really want to improve the value curve, then what we want to do is deliver the highest value items first. So we need to have a look at what we've got and prioritize those items that are going to actually deliver us value or deliver your customers value. And when I say your customers, if you're doing contract work for a customer that's not the actual end customer, it's for the actual end customers that you need to optimize your value. So what I'd like you to have a little think about now, just for a couple of minutes, and talk amongst yourselves, is how you currently ensure that value delivery. What are you doing currently amongst yourselves? So talk amongst yourselves just for a couple of minutes, and then I'll ask around, just see what techniques you're already using. Okay, so if you just talk amongst yourselves, just a couple of minutes. What did people discuss? What are people already doing? So put your hands up if you've got something you want to share and say, I discovered something, or someone said something to me that was interesting. Anyone got anything to share? Yeah, go on, Ismail at the back. Wireframes and prototypes that you might do. Try and get the value early. Yep. Yeah, indeed. So you're splitting stuff up at the beginning of the project and then showing that to the customer. So I'm just repeating what you're saying just in case people can't hear you at the front. And then you're showing that to the customer and then helping prioritize those items with them, so you put them at highest value items first. Anything else people are doing? Yep. Persona creation. Anything else? Yeah, go for it. Ask the business what's the most important thing to them, because they'll have an idea as well. And it's about meeting everybody's needs. You've got the business, you've got the customer, you've got your needs as developers, and you need to meet everybody's needs if you're going to deliver value. Not just about your customer, not just about the business, not just about developing stuff for you. It's about meeting everybody's needs. Okay, so what I like to think about optimizing the delivery curve is three things. And these are the 3 steps. Optimize for flow efficiency. I'll talk about that in a minute. Visualize the work. Now, who here is visualizing their work? They got Kanban boards, Scrum boards? Yeah, a few people are already visualizing what they're doing. And then focus on continuous improvement. People doing continuous improvement? Ooh, less people, much less people. And focus on, so these are what I call the 3 steps to improving your value. These will improve your value delivery curve. So what do I mean about optimized flow efficiency? Okay, well, the dictionary definition of flow is a steady continuous stream of supply or something. So if we go back to thinking about that Henrik Nyberg slide I showed you earlier, it's about constantly delivering, not delivering all at the end. It's about delivering things all the time. So continuous delivery, techniques like that. And flow is important because it allows us to optimize the value delivery and eliminate waste. Because that's the other thing. We don't want to deliver waste. We don't want to waste our time as developers. We don't want to waste our customers' time or money. So what we need to do is make sure that we're not wasting anything. And if we focus on flow more than anything, then we'll start to eliminate waste. And it also allows us to focus on the overall delivery time, because that's the thing that we want to get down if we're going to deliver value early. Flow is quite difficult to do because we have bottlenecks. We have handoffs between people. We have maybe another agency involved or a department that you need to contact to do releases. Those bottlenecks cause queues and they ruin our flow, and they mean that we can't deliver that value early. Variation, and the more we have to do, the more our utilization goes up, the more that variation in work will hurt our flow, and so we won't be able to deliver that value early. And there's Little's Law. Now, who's heard of Little's Law here? Wow, nobody at all. Okay, Little's Law. Right, I've got a couple of slides just for this event. So Little's Law describes, it's from queuing theory, and it describes the relationship between work in progress and the speed at which we can complete the work and the time that that work spends queuing. Okay, so basically what that means is the more work that we have going on, the slower we'll go. So the more work that you commit to, the slower you'll deliver over time. And what we need to do is reduce the amount of work, the work in progress, the work that's going on, if we want to get quicker at delivery. And for those who enjoy a little bit of maths, there's Little's Law in all its glory on a slide there. And as you can see, cycle time, that's the amount of time it takes to do the work, and we can see the relationship between those. So if we know how much work in progress we have, we can, and how long our average lead time is to deliver a feature, we can work out things like the cycle time, we can work out things like the throughput, and we can actually use that to model the work that's going through our system. But the important thing to remember about Little's Law is less about the maths and more about the fact that if we reduce our work in progress, then our capacity to deliver early and deliver often will actually go up. It's a little bit counterintuitive, and a guy called Nicholas Modig wrote a book called This is Lean, and in it he drew this sort of quadrant. And this talks about flow efficiency and versus resource efficiency. Now, resource efficiency is what traditional management would like to happen. And that's about efficient islands, people 100% utilized all the time, doing their little bit of work, understanding exactly what it is, handing it off to the next person, doing their little bit of work. So your waterfall, classic waterfall sort of project or phase gate project. Whereas efficient ocean down here is where we optimize for flow efficiency, but we optimize to such an extent that we no longer have resource efficiency. So effectively, you just have a room full of this many people and you have one work item. Yeah, that work item will get really done quickly, but our resource efficiency is not there. And that's why it's the efficiency paradox, because we need to balance between those two states. And that's quite hard to do. And he calls lean the perfect state. And again, he's drawn a little line on there about the variation. I spoke about the variation before. So variation in work, size of work, variation in people's availability, people like that will push us out of the perfect state. But the point is we need to start thinking about optimizing for flow efficiency, whereas most management training will tell you to go up here into efficient islands. So theory X, theory Y. Anyone know anything about theory X and theory Y? Okay, so theory X, theory Y is a view that if you're theory X sort of person, you believe that people need to be told exactly what to do. People need to, if they don't have clear instructions, they won't do it, and they'll just sit around and goof off all day. And theory Y is people will, you give them a good task to do, rather than just telling them exactly what to do, they'll get on and do it themselves. The theory X up there, efficient islands, we have to tell people exactly what to do. Theory Y over on the right-hand side, where we're more about flow efficiency and letting people get on and do their work themselves. However, down here in the wasteland, we've got neither. And to be honest, I suspect most companies are actually in this red box. They'd like the managers think they're in the green box, but actually they're in the red box. So there's still benefits to be had, even if we think we're there. We can make our way up the quadrant. It'll be a zigzag path. That's why we do continuous improvement. So thinking about flow and thinking about things that stop your flow, is there anything that you've seen in your work where your flow has been interrupted in terms of the work that you're doing? So just have a little chat for a couple of minutes. Sorry, yeah, so say 5 minutes, 2 minutes. Just have a little chat amongst yourselves, and I'll quickly ask. That's great. So what's anyone got to say? Has anyone learned anything about sort of lack of flow and what they're doing at the moment, or any insights anyone wants to share? Yeah, go for it. Micromanage answers from a client. Yeah, absolutely. That's really going to mess with your cycle times because you're waiting for them to get back to you and things like that. Yep. Lack of resource. Absolutely. And what's the answer to that one? Limit your work in progress. Yeah, definitely. Yep. Too many people giving input. Yeah, absolutely. The old classic. Everybody gets in, and no one makes a decision about anything. Yep. Any more? Okay. Oh, yeah, absolutely. So lack of content, so they don't supply something to you that you need. Yeah. Any more? All done. I feel like I'm doing I feel like I'm doing an auction. Any more on the lack of content? Anyway, right. So to optimize flow. So let's talk a little bit about how we might optimize flow. So what we need to do is we need to see the big picture. Now, flow is not something that just occurs when you're doing a bit of development. It's about the value delivery across the whole thing. So it's not just our development. So imagine this. This is a very crudely drawn value stream. And we start off over here, and that might be, making the sale, and then it goes off and is scheduled, and then it goes to the development team, and then something happens to it, and then it goes to the deployment team. So it's not just about your little bit of work in terms of development or sales or whatever you do. It's about the whole system, and flow needs to go across the whole system. We need to look at that system as a whole, not just our part of it or one single part of it. Yes, right. Okay, so I'm now going to show you the effect of flow using a sort of a crude motorway model. Now, obviously, we're all seen motorways and cars and queues and traffic jams and things like that, so they make quite a good analogy. Now, in my head, when I did this, so fair warning before I show these slides. In my head, I had this grand vision of sort of a great interactive demo with motorways and cars, and you could smell the fumes and you'd all be terribly engaged. Unfortunately, what I ended up with was this, which was not quite what I was after. But I think it does a reasonable job. These blobs are cars. And these are motorway lanes. Right? Well, I'm using a motorway because motorways they are limited in their capacity to the amount of cars that they can take. Because we know what happens if we put too many cars on a motorway, we get traffic jams. So anyway, on this motorway, we've got three cars, 3 lanes rather, and I've got steps. They would be sort of motorway junctions, or they would be the steps in your workflow. So at the moment, we've got a normal day, and the cars are flowing freely, and people are getting to their destination, and that's absolutely great. Now, rush hour happens, and this is what occurs. We've got a load more work has come in, and the first thing that happens, we start queuing. People start queuing, and the people at the bottom of that queue have to wait a long time before they get to their destination. So this is your work, and it's queuing up, and this is Little's law in practice. The more work we put in, every step takes an amount of time to do, and if the work's coming in faster than we can do it, then the queue will just go up. And the longer the queue gets, the longer people have to wait to get to their destination. And before long, we've got total gridlock because everything's full up. We can't take any more at all. So we've still got queuing. Everyone's fully busy. And see, I said fully busy. If we think back to how I showed you on the quadrant and how managers often think about, well, we need to all be fully busy, they might look at that and go, oh, that's a really good thing. Every slot is full. We're at full capacity. This is where we want to be. But of course, that's not where we want to be because everyone's queuing and waiting. We're not actually making progress. One car has been actually delivered, but our manager's going, yeah, this is fantastic. We're all 100% utilized. So it's about changing that thinking about being 100% utilized to how many cars are actually getting to the destination. And then things get worse. Pink car's turned up. A pink car's got a VIP in it. And the VIP wants to get to the destination as quickly as possible, and that's really important. And there's no capacity for them. So they get stuck in the traffic, and they weave and they dodge. But it takes them ages to get anywhere, and it slows the whole system down because we're focusing all our attention and trying to get this person to their destination. So by looking at, we've seen there's a few problems. Okay, we had too much work going on, and then something came along, some variation. Another type of car came along which was more important than the other cars, and we had to do something about that, and that just bogged the whole system down. So when we look at that and we see things like that happening, we get to the third stone that I mentioned at the beginning, which is continuous improvement. So how could we improve that motorway simulation? Crudely cut out, posted. It was so much better in my head. So how do we improve? Well, this is the Deming improvement cycle. Anyone heard of the Deming improvement cycle? Plan, do, check, act? Yes, people I've spoken to before. Okay, well, Deming was a guy just after the Second World War in Japan. He was an American. He went out there and he worked with them on rebuilding their economy after the Second World War. And he worked with the people at Toyota, and from that came the Toyota production system, and from the Toyota production system came lean and a lot of agile practices that we do today. So Deming is the sort of father of all of that stuff. There's some other people as well. It's sometimes called the Stu Hart cycle as well, because some controversy who actually came up with it. Anyway, so this is an improvement cycle. And what it is, it's a way of doing sort of experimental continuous improvement. And what we do is we plan what we're going to do, and then we do it, check whether it worked, act on those results, and then go around and do the cycle again, keep doing experiments. So in this circumstance, what we do is we go, okay, what was the problem? We had a special pink car and all our traffic was all blocked up. Well, we can't fix everything all at once. We can only fix one thing at a time. Well, what was the most high priority thing on that? And we talked to our managers and we talked to the people who are in the cars, and they said, well, actually the pink car was the most important thing. So, okay, well, we need to devise an experiment for getting pink cars through more quickly. We made our plan. We're going to do something. And so we come up with a new rule that we're going to have a special pink lane. So anyone here in the Olympics, you would have seen the Olympic lane, did a similar thing. You've got VIPs, you want to get somewhere, we'll dedicate a lane just to pink cars. So that's what we're going to do. We'll do that. We'll see how that goes. And if that's okay, we'll act on it. And what we do is we make an experiment which is safe to fail. And that's very different from fail safe. Now, fail safe is what a lot of you will probably have come across, is we cannot possibly fail at this. If we get this wrong, terrible things will happen. We can't let this project fail. We can't, that sort of thinking. And the trouble is with that is you're paralyzed then. You never get anything done because you're so worried about it going wrong, you never try anything. So we need to switch that around and think, get yourself to safe to fail, which is we do small enough experiments and we decide to do an experiment that we know might possibly fail, but we have some way of getting out of that. So it's small enough, or there is some way of rolling back the change that we tried. So it's important to make your experiments safe to fail, but don't fall into the trap of being fail safe, i.e. we cannot possibly fail. Think, yes, this experiment might not work, but we'll learn something. If it doesn't work, we'll learn something. So here we go. We're back to the cars again. So now we have a priority lane for pink cars only. And we can see normal day of traffic. Again, rush hour. We're not trying to solve that. The cars are blocked up. But of course, our pink car turns up and can drive straight across. Great. Experiment worked. So what we do now is we go back into the planning cycle and we try and deal with the next problem, which is rush hour, peak in our demand, or variation again when we go back to that quadrant. So what I'd like you to think about now, just for a couple of minutes, it says 5 minutes ago on this slide, is how you currently manage improvements. Are you doing anything like that, plan, do, check, act, to do your improvements as you go through? So just talk amongst yourselves, a couple of minutes again, and then I'll ask some questions. People are currently managing improvements, or not, as the case may be. Yeah, go for it. Yep. Doing sprint retrospectives, yeah. And how do you manage the improvements from that? Do you pick one thing to improve? Do you run? Yeah. Yeah. So you do short improvements that last however long your sprint is, week or two, whatever. Anyone else? Yep. The issue that you have is someone somewhere, probably senior, is going, this one is the most important thing that you should all be working on. I don't care about anything else. Let everyone else's work go to. Okay, yeah. Well, we'll talk about that in a second. Anyone else? No? Oh, go on. Improvements realistic that you can actually be achieved. So again, keep them reasonably small. Anyone else? Yes. Excellent. Checks in the post, Pete. Yeah, so yeah, you can create an experiment board where you can put your experiments up and track them and work in that way. That's a really good idea. Oh. You can have one too. Cool. Yeah, go for it. General improvements. So you not just process improvements, you'd have improvements for the whole team and almost organization level. Yeah. Okay. Super. We all done? Yeah, go for it. Yes. Mm-hmm. Based on actual customer problems that they're having with your system. So you then show people before you actually release it, have a beta version of your website. Excellent. Anyone else? No? Good. Okay. So we go to our next model. We've done the motorway. Now go to suitcases of value, which sounds slightly more impressive than it really is. Woo! Wow. Okay. So this is really just an exercise to get us to think a little bit about how we prioritize and assign value to things. So what we have is 4 suitcases. And how sometimes we look at things, we look at just how difficult they are to do. So how heavy are the suitcases? So if we look at how difficult these things to do are, or how heavy they are, it's relatively obvious the priority. Suitcase 1 weighs 10, suitcase 2, okay, it's 50-50 which one we deliver first. But 3 and 4, they're pretty light, so we can not worry about them and do those later. But of course, we haven't actually looked inside the suitcases at this point. We don't know what's inside them. So if we open them up, we've got one that's full of gold, one that's full of bricks, one's got a ticking bomb in it, and one's got a handheld X-ray machine. So which one now is most valuable? Ticking bomb. Sorry? Handheld X-ray machine. Okay, so why do you think the handheld X-ray machine is the most? Excellent. Yeah, so you can figure out what's in the other ones without as much work. Yeah. Okay. The actual answer is it depends. Entirely depends on who your customer is. If your customer's a jeweler, yeah, maybe they want the gold. If your customer's building a house, maybe they want the bricks. If we deliver the bomb, we can stop it going off. Well, yeah, okay, then that really is the highest priority. And we can use the X-ray machine to look for future bombs. But that means it depends. It depends on what your value is. And this maps to something called cost of delay. So there's a cost of delay for each of those suitcases, depending on who our customer is. Now, obviously, our bomb is expedite. It has a huge cost of delay. We don't deliver that, the thing's going to go off, cause us all sorts of problems. That really is a pink car, not a grey car. Have standard, that's your sort of stuff that you want to get delivered as quickly as you can, but you might want to schedule it behind an expedite item. And that would be if you're a builder and you need the bricks, or if you're gold and you need the bricks. You have the horrible world of fixed date items. But the thing to remember about fixed date is they don't have a cost of delay until they get to that date. So when you're scheduling them, there's no benefit in doing them early. So you might want to schedule things in front of fixed date items. depending how long it takes you to go through the cycle. And of course, that's why we're focusing on flow, because it gives us the ability to move things around and potentially do stuff in front of fixed date. A lot of the time, what happens with fixed day, everyone panics because, oh my God, it's fixed day, we better do that immediately. And then they don't do the expedite ones, or they mess up the standard work and things like that. And intangible, that's our X-ray machine. We're not sure that that's going to give us value because we don't know how many bombs we're going to get in our suitcases in the future, but there will be some value to it at some point. So that's a low value item that we might want to deprioritize, but it's not got no value. So we do want to do it at some point. And these are used a lot in Kanban to set your what are called classes of service. So that's effectively the colors of your cars on your motorway. And you use those to do scheduling and work out what the value is and whether we should deliver them first or early. There's all sorts of other ways to define value in Agile. We've got relative weighting, value points, Moscow, which is must have, should have, could have, won't have. Pete, I know you've used in the past. CD3, which is cost of delay divided by duration. So we work out how long an item is going to take. We work out what its cost of delay is, and we set a number against it that way. And Hippo, which someone also mentioned, which is the highest paid person opinion, which is the grey car situation. So what you have there is the classic Hippo. And they go, my opinion is higher than everybody else's because I get paid the most money. So there are all sorts of different ways of defining value, but the important thing is what we do is we work out what the true value is, and that means thinking about the customer and thinking about value in terms of what that cost of delay might be. So if we have a feature that we don't get launched and it's going to cost us £3,000 a day all the time that it's not there, then obviously that's got a high cost of delay, but it might only be $50 or 50p if we don't launch it. Relatively low cost of delay. So we can prioritize, and then we're prioritizing on real things, tangible things, on value, on what it's worth to us as a business or to a customer, not just prioritizing based on some sort of nebulous, well, we think that probably should go in front of that one. And that helps us to have those discussions. If we're drawing those little graphs, we're thinking about things in terms of cost of delay, and someone goes, I'm the Hippo and I want my thing in front of everybody else's, we say, okay, well, what's the cost of delay of us not doing that? It's absolutely fine. Maybe you're absolutely right. You have full view of the business, so you know what the cost of delay of that item is, don't you? They probably don't know the cost of delay. It means that they're probably just stating an opinion about where it should be. But if we start looking at things with actual values, some actual method of defining value, then we can make intelligent decisions about what comes first or what goes next in front of one thing or another. And if we're focusing on flow and reducing our work in progress, then these are the sort of trade-offs we're going to need to make, because we're not going to want to do it all at once. Okay, so how do you currently prioritize value in your organizations? 2 minutes again, just talk amongst yourselves and we'll come back again. To an amount of pain. Wow. Okay, so what's causing your clients pain? That's what you try and prioritize first, not what's causing you pain. And what's causing you pain as well. Okay, yeah? Yeah, go for it. Prioritize the work based on the value of the client effectively to you. Okay, and I guess that has a cost of delay. If you don't work for that, if you don't do this client first, then that's going to cost you a lot in the long run. Yeah. Yeah, go for it. Yeah. Was someone at the back? Go on. So you prioritize based on whether you can actually do the job or not in-house. Yeah. Yeah, in some cases. Yeah, go for it. And that's truly looking at the customer we spoke about before. You know, not their customers as such in a charity, but it has a real tangible effect if you don't get that into production in a certain amount of time. Yeah. All there? Okay. Right, well, we're almost at the end, so I'll sort of recap where we are. So try to start thinking in terms of flow efficiency rather than resource efficiency. Map and visualize so you can actually see the work at hand. That's quite a big thing. That's quite important, because if you can't see a lot of knowledge work, programming tasks, that sort of thing, you can't actually see what you're doing You need to be able to see what's actually going on. So mapping it and visualizing it is very, very useful, because then you can see where the bottlenecks are. And if you're using things like burn down charts or burn up charts or cumulative flow diagrams, whatever tool you use, you can start to use that to look at where your flow, where those problems are, where you can start to find ways to bring improvements in. And of course, finding ways of defining value. So that might be in the third sector, impact of delay or cost of delay, finding ways that are real and tangible and tie into your end customer or user, rather than going the classic hippo route. I'll just remind you again of what these the three stones are. Don't get bogged down in methodology. That's one thing I will always say. Scrum, Kanban, DSDM, waterfall, whatever it is, it doesn't matter. More important that you think about the principles and values, not necessarily the methods and tools. We often get bogged down at the method and tools because they're tangible. You can implement them. You can go, oh, if I put this tool in, this will improve things. And really, tools should grow and evolve out of our principles and values. And my recommendation, now obviously context is everything. There are no best practices, there are only good practices in context. So these are things that I've seen working. They may not necessarily work for you. So any value or principle has to be appropriate for what you do. But optimizing for flow efficiency, visualizing your work, and focusing on continuous improvement are three simple steps that we can take to try and make value delivery a little bit quicker, or value delivery a little bit more ingrained into what we do. This is probably more for when this goes online. There is a list of interesting blogs and books. There's This Is Lean, very influential book. Oding and Alstrom, Kanban, obviously, David Anderson, Hack and Force, if you've ever heard of him, and Henrik Nyberg, and the guy called Flow Chain Sensei, who has taken this idea of flow really quite a long way forward. So he's worth looking at. But that's it. I think I'm almost out of time. There's probably a couple of minutes if anyone has any questions. Go for it. Okay, convincing people is hard. You can't make people do anything. They have to want to do it themselves. But what you can do is start from where you are. And Kanban talks a lot about starting from where you are. Not changing anything. Respect people's roles. Respect for people is one of the central tenets of all lean implementations. So you start from where you are. Visualizing, well, I can't imagine they'd have any objections to visualizing, so you can see what's going on. And at that point, you can show them and say, look, things are blocking up here. And then you can start having that conversation. But it will be organic and it will grow. There's no big bang, there's no silver bullets. We have to go in and we have to convince people by showing them what's going on. And that's why visualizing is so important, because we can actually show people where the blockages are. And respect for people, always. And start from where you are. Any more? No. Oh, yeah, go on. The post-it notes are the obvious choice because they allow you to model it and change it as you go, because you won't get it right. My preference is Sharpies, post-it notes, and big A3 bits of paper to model all this stuff, certainly to start off with, because what you don't want it to become is something which is set in stone early on, because you're going to be doing lots of experiments and trying things out and changing things, and maybe you didn't map the value stream right to start off with, or didn't quite understand all the different parts of the organization which led into yours. So you want things that you can change and are malleable, so you don't get locked down. A lot of the trouble is a lot of the electronic tools is they're kind of difficult to change, or they don't quite reflect the steps that you want to have. So electronic tools tend to come further down the line. The exception to that is if you've got distributed teams. If you've got distributed teams, then you'll have to start with electronic, but just realize that it's going to be more difficult to change things and not get too sort of bogged down in that. Anyone else? Yes. You've just said there is it will depend on the context that you're in, and what will work for one person won't necessarily work for another. But cost of delay, divided by duration is useful because it does give you, it joins together two numbers which are normally apart. And to be honest, once you're comfortable with cost of delay, then I'd probably recommend you start doing that almost immediately, because that will give you the most value, because it will give you a slightly more rounded picture on what its actual value is, rather than just one facet of value. Because value is kind of, it's a multi-dimensional figure a lot of the time, but it can be quite difficult when you're starting out to capture things in more than one dimension, because you're probably not capturing it in one dimension at the moment. So start, being humane about things and evolving things gently. We'll probably start with cost of delay, because that's relatively easy to get your head around, and then move on to slightly more sophisticated ways of doing things. But what you don't want to do is just jump straight into the really complicated way, or a way that's much more complicated than you're doing things, because that's a big change and you might get resistance doing that. And what you're doing, if we go back to the PDCA circle, we want small experiments and small changes that we can test and see whether they work. So in that instance, probably I wouldn't recommend, I'd test. Go, let's do it this way. Has this given us value? Can we get any more value out of doing this if we do another version of it? Yes. Calculating that is again, context will be everything, so I can't give you specific advice. But again, that's about reducing your work in progress. So what you might do in Kanban is you might put limits on each step and say we can only have 5 cards at a time. Try that out, see how that feels. You might set them too low and you get starvation further up the process if you do that, or you might set them too high and no effect. But what you can do is we do cycles of improvement. We can have a look, we can try out setting them out. There are specific things you can do about demand shaping and modeling, that sort of stuff, but that's probably a bit complicated to explain right now. But if you want to talk to me, I can probably talk to you afterwards. No more? Excellent. I think I'm pretty much bang on time there.